Okay, so we're doing the derivatives of the trigonometric functions, and today is sine and cosine, and tomorrow is the others. And then, we're getting close to finishing off all of the trigs. So today you'll be able to do like the next question on the assignment, and then by the day before it's due, you'll be able to do the last question on the assignment. But let's take a look. This is the derivative of the sine function. So we have the sine function, right? It's the sine function, 0 and pi over 2 and pi and 3 pi over 2, 2 pi, and so on. So we have two periods here, right? And the green line here is the tangent line, and this graph here is going to be the slope of the tangent line. So let's push play and see what happens. So as we go along, so now we hit 0, right? Now it turns negative. Okay, and then it hits 0, and then it turns positive, and it's climbing, and it's getting, and then it hits 0. And so what function are we graphing out here? What is that? That's the cosine function, right? So the derivative of sine is cosine. Cool, huh? All right. So derivative trig functions. Now we find my notes. So the derivative of sine. Now, if you want to see a proof of that, there is a proof in your book, right, showing how you get the derivative sine function in terms of first principles, right? F of x plus h minus f of x over h, limit as h approaches 0 of that, and your function is sine x, and you get sine x plus h, and so on. Anyway, that's in the textbook. If you're interested, you can look that up. I just thought better to cut to the chase and show you the graphical. Oh, look, hey, it looks like cos. Yes, and it is. So it's cosine function. And the derivative of cos x is equal to minus sine x. Okay, so those are the two that we're working with today. So what do you know about this sine function here? It's reflected in the x-axis, right? So that it's going to go down instead of up, right? Okay. So always keep in mind, kind of what, right? That's y equals sine x. And that's y equals cos x. So keep in mind what these guys look like, right? We need to know with respect to, your exact values, right? And, same deal here. Well, okay, scale's a bit different. Okay, so, when are things 0 and when are things 1 and when are things -1, right? So you're going to want that knowledge handy, okay? So, what is d by dx of the sine of 3x? So, that's kind of chain rule type thing. We have two functions. We have the outer function, which is sine x, right? Sine or sine u. And the inner function, which is u, right? Which is 3x. So chain rule says that it's the derivative of the outer function with respect to the inner function. So that's the cosine of 3x. I don't know why I put brackets around that. Times the derivative of the inner function, and the derivative of 3x with respect to x is 3, or 3 cos 3x. Right? So the derivative of sine 3x is 3 cos 3x, right? Using the chain rule. Here's one for you. Do for me the derivative of cos 5x. Okay, here, I'll scooch this up a smidge. Scooch and smidge. So now all you're doing is sort of, well, let's see, if I do it like you did that one, then I will get a result of and then if I rearrange it, so yeah, you kind of do it as, I kind of know what that is, and I'm going to do the rearrangement in my head, but I'm going to stick with, well, okay, so it's the derivative of the outer function. The derivative of cos is minus sine. So minus sine of what? Well, it's with respect to the inner function times the derivative of the inner function, which is 5. Keep it that, I kind of keep it that way, I think. And then, so that's one more line I write, and then we write minus 5 sine 5x, right? And, you know, it sort of keeps it. You could do it and just say, well, it's going to be minus sine 5x times 5, so I'm just going to write minus 5 sine 5x, right? And that's cool, too. So either write this, then it becomes this, or you can just write this directly. Just as things become more complicated, it's not a 5, it's like an x squared minus 1, then you don't want to be messing with. Okay? So it's better to stick with a, I'll do this, then I'll do this, right? I'm just going to do the chain rule the way that I've done the chain rule 100 times before, and then fix it up to worry about making it pretty later. Okay, moving on. Well, what are derivatives anyways, right? So find the equation of the tangent line. To y equals 2x sine x at the point pi over 2 tangent. Now I could just say when x equals pi over 2 and make you do some work, but I'll give it to you. So, well, what is that? It's pi over 2, and then that would just be pi. Okay, so if I had said when x equals pi over 2, you'd have to plug the pi over 2 into the expression and figure out the y value. So here I've given it to you. So we got a point. What do we need? We need a derivative because we need a slope. And what's the slope? It's the derivative. Okay, so let's find the derivative. Well, looks like product rule, right? We've got a product. We've got 2x times sine x. So we take the first function, 2x, times the derivative of the second function. So 2x times cos x plus the second function times the derivative of the first function, which is 2. And then we go, well, so that's 2x cos x plus 2 sine x. Then we say, well, now, what do I need? I need the slope at that point, so I got to put a pi over 2 in for x. So when x is equal to pi over 2, then m, let's just go to m. So we'll say m is equal to 2 times pi over 2 times the cos of pi over 2 plus 2 times the sine of pi over 2. So 2 times pi over 2 is, well, who cares what 2 times pi over 2 is, because the cos of pi over 2 is 0. So that first term, 2 pi over 2 cos pi over 2 is 0. So look for that before you do any fancy stuff up here, right? Like you may have a more complicated thing and you're starting to partially calculate the complicated and you realize, well, that's 0. Okay. So what's the sine of pi over 2? 1. So this is equal to 2. Okay. Do you want more detail on that, or is that good enough? Good? Okay. So, again, when you're doing your work, you put in as much detail as you need. So if you want to fill that in and go, it's pi times the cos of pi over 2, you know, it's pi times 0 plus 2 times 1, then that's cool, right? I mean, you can just move this down, and you can write it in here. Shouldn't have the dot there. So. Okay, so if you want to do that, you go, okay, look, 2 times pi over 2 is pi, cos pi over 2 is 0, plus 2 times, well, 2 times sine pi over 2 is 1, and that's equal to 2. Good. Then you use your favorite method for finding tangent lines. Whatever you like. So y. And what do we get? Y minus pi is m. So we, oops, not m. M is 2. Okay, or maybe you like y equals mx plus b and you solve for b and you put it back in, or maybe you like y minus y1 over x minus x1, whatever. And so 2x minus y equals 0. So I got to move the y minus pi over, right? So it'd be 2x minus y, and then I'm going to add pi to both sides, so minus pi plus pi. 2x minus y equals 0, or y equals 2x if you like slope-intercept, right? Hey, it's y equals 2x. Right. And we could graph that and look at it and say, hey, that looks like what it should look like. Oh, it even said on here, let's use Desmos to graph. Okay. Where is it? Loading. Or let's not. So, oh, here we go. Okay, what did we have? 2x sine x? Y equals 2x sine x. And we had y equals 2x, really? And we were looking at the point pi over 2. That's about 1.571. Actually, it went to that point because that's where they intersect, right? So that is the tangent, and then that's pi, right? Pi over 2, pi, rounding, yeah. Okay, so good stuff, eh? It works. How about this? Y equals the sine of x squared. All right, well, there's two functions there, right? The inner function, x squared, there's an outer function, the sine of something, so it's chain rule. So it's the derivative of the outer function with respect to the inner function, so that's cos of x squared, times the derivative of the inner function, right, which is 2x. And writing that out nicely, we get 2x cos x squared. Okay. Again, if at any point you have any questions, contrast that with y equals sine squared x. What does sine squared x really mean? It's our short form way of writing the sine of x all squared. Right? Take the sine of x and then square it. And that's what we understand. We say sine squared x. It means you're going to find sine of x and then you're going to square it. Okay? So, our outer function is you are squaring something. So our derivative will be 2 times the inner function to the power of 1, right? Times the derivative of the inner function, which is cos x. Okay? So this is the derivative of the outer with respect to inner. Okay, and wait, let's be more specific. This is the derivative of outer with respect to the inner times the derivative of the inner. Okay, or just the chain rule, right? Got that? Okay, f of x is the sine of the cos of the sine of x. I wonder what that looks like. I have no idea. But I do know that it's derivative. Okay, so we take the outer function, which is sine. So we take the derivative of the outer, which is cos of the inner, which is cos of sine of x. Yeah. Times the derivative of the inner. So let's just be kind of specific here. So d by dx of that. Okay, so our outer function is sine of something, right? What's that? I don't care what the something is. I'm just going to do the derivative of sine, which is cos, and then write in the something, whatever's in the brackets, times the derivative of the inner, which is this. So now we'll do this derivative, right? So we've got the cos of the sine of x times, well, it's okay, we're just doing the same thing again, right? Derivative of the outer, so it'll be minus sine with respect to the inner. So minus sine of the sine of x times the derivative of the inner. And we'll be really explicit with this one, right? In doing it, because it looks a little more complicated, right? It's a little more, what? So we've got the cos of the sine of x times minus sine x times cos x. And we're just going to put that all together. We'll go simple to complicated, right? So the most simple thing you can do is take the negative. And then we've got cos x. And then we've got times the sine of x. And then we've got the cos of the sine of x. Right. And there it is. Right. And what is that? That's f prime of x, right? Okay, lots of chain rule. Remember the video? I wish we could use the chain rule more often. I mean, you get to use the chain rule lots. I wish we didn't get to use calculators. You don't get to use calculators. You even got one of the wishes that was there, right? Don't get to use calculators. And hopefully you do understand the professor's accent. There's no professor. All right, let's do some higher derivatives, because why not? We just did higher derivatives, so. Find y prime and y double prime for a y equals cos. Okay, so if y is equal to cos x squared, you should all be able to do y prime. So you do y prime, and I'll give you a head start. I'll eat some more of my lunch, which is very quickly congealing into it. There's some egg in there. A little bit of red pepper. Okay, is that good? And so now you can pair it up. Come on, move down. There we go. Now I want to take the derivative of that, which is going to involve a product, right? So it's going to be negative 2x times the derivative of sine x squared, which is chain rule, right? So the outer function is sine, so that'll be the cos of x squared times 2x. Okay, so now there's way less detail. Okay, so product. So minus 2x times the derivative of this, sine x squared, which is cos x squared times 2x, plus the derivative of this, which is minus 2, so then really I guess it's just minus 2 times the sine of x squared. And so we get what? Negative 4x squared cos of x squared minus 2 sine of x squared. Now, if there's no particular reason to factor out a negative 2, then don't bother. It's like that's good like that. And then, since we did the cos of x squared, what's the next one we're going to do? Cos squared x. By equals okay, so remember that's cos of x all squared, right? So the outer function is squared. So we do the derivative of the outer function, which will be 2 times the cos of x times the derivative of the inner function, which is cos x, which is minus sine x. So we get negative 2 cos x sine x. And now we do y double prime, right? We do the second derivative. So my first function is negative 2 cos x times the derivative of the second function, sine x, which is cos x, plus, which is really going to be a minus. So we've got the derivative of the second, derivative of the first function, so that's going to be actually minus 2. Oh, wait, but then that'll be minus a minus. Hang on, let's just do this. Minus negative sine x. Oh, sorry. Minus plus negative 2 sine x times sine x. Yeah, wait a sec. What did I do here? Oh, wait, sorry. The derivative of cos is then so I'm doing this minus 2 sine x times the derivative of this. Okay, so minus 2 sine x times the derivative of cos x. So negative 2 cos squared x plus 2 sine squared x. Okay, good. Ready to move on? No? Still confident? Yep.
Can't you just take out the 2 and put it down again?
Yeah, you could do that too. Yeah, take out the 2 first. Just go 2 times the derivative, and here's what's left.
Yeah.
Yeah,
Is that, yeah.
if you like.
Either one.
Either way.
Convert it to like a trig identity.
It's not going to be cos squared plus sine squared. It'd be like sine squared minus cos, sine squared minus cos
For the
squared.
first one, if you take out the
Oh.
the negative and 2 cos x sine x is just sine 2x.
That happened then or earlier one?
All right. So that's. What is it? Sine 2x? So like so?
And you just do that.
We try to make stuff easy. So what do we got there then? We've got over here, so it would be cos 2x negative. Is that another? There's going to be another identity then, right? That, better have the identity sheet handy. 2. The cos of 2x is 2 cos squared x minus, it's cos squared x minus sine squared x. Yeah, so. Yeah, same thing. So watch out for identities then. They may pop in. So where that becomes interesting is multiple choice answers then, right? You see this, and it's this. And you've got to recognize they're the same, right? So you start looking around, and you do have the sheet, and you go, oh, wait, cos squared x minus sine squared x is cos 2x. So from here then, cos squared x, so we want to do what? Factor out the negative 2 and get and then just get good catch. Yeah, and so if you recognize that, up here, then this becomes a little bit easier, right? You're not going through all of that. If you go through all of that, in the end, it doesn't matter. It's still, they're equivalent. And worst thing comes to worst, when you don't see your multiple choice answer, then that's when you're pulling out the sheet and saying, okay, this is trig, identities, is there anything on here that is applicable? Because that'll happen on the assignment, so you're going to want to watch for that. If you can simplify something sooner, do so. It makes life a bit easier. So thanks for bringing that up, because find the 27th derivative of cos x. Okay, where you go? You only got to do 26 of them, and then you get the 27th one. Or could there be an easier way?
Can I replace one of the pages of the packet?
Sure. So if f(x) is cos x, then we do f prime, which is minus sine x. Then we do f double prime, which would be minus cos x. We do f triple prime, which will be positive sine x. Then we do f4, which will be square root of sine is cos. And derivative of cos is minus sine. Wait a sec, I seem to be in a repeating pattern here, right? So I probably don't have to keep going until I hit 27. Okay, so we could say, well, all right, look, so f prime of x is negative sine x, and so is f5. And so then, what's the path? So 1, 2, 3, 4. So then, if 5 is, so that's 1, and then 5, and then 9, and then 13, and then 17, and then 21, and then 25, and then 29. Okay, 25. That means this 26, and this one will be 27.
Okay.
Well. So I got a repeating pattern of 4, right? There's a cycle of 4. It's going through 4 things, right? We go from minus sine x to minus cos to plus sine to plus cos to minus sine, okay? So the first derivative is negative sine x, and so is the fifth. So the first, second, third, fourth, fifth, sixth, 7, 8, 9, 10, 11, so it's every 4. So I just pick one at random. I mean, if I knew that, if I back up 27, I guess, so 27, 23, 19, 15, 11, 7, 3, okay, then it's 3. So that would be the 27. Okay. Or on a test, if you just want to pound away until you hit 27, that's perfectly fine. Brute force works. Doesn't work as well when it's the 999th. At that point, you really, then that's sort of brute force there, 5, 9, 13, but it's like, I can either figure out the sequence or I can just pop off a few numbers till I hit something around 27. Okay, so next. We're going to arrow going. Oh, this one. Yeah, I like this one too. So the sine squared of x squared minus 1. Chain rule, right? So the outer function is squared, right? It's the sine of something squared. Remember sine squared of that. If you want, write this down. Okay, so it's squared. So it's 2 times the sine of x squared minus 1 times the derivative of the inner function, which is just 2x. Times the derivative of the sine of x squared minus 1, right, which is the cos of x squared minus 1. Okay, so outer function, the outer function is 2 times the sine of this to the power of 1. Inner function, which is 2x. Other inner function, right, because that's sine, so we have to do the cos of x squared minus 1. Okay, so double application. Which is, what do we got? 4x sine of x squared minus 1. Now somebody's sitting there going, hey, the identity sheet, where's the identity sheet, saying, is there something that, there's some sine of 2x is 2 times sine x cos x. Well, I've got like sine x cos x. I got the sine of something times the cos of something. If I can make that 2 times that, well, how do I do that? Well, let's pull out a 2x and be left with 2 times sine something times cos something, right? I mean, that's 4x, so that's fine. But this, right, is 2 times sine x cos x, which is the sine of 2x, right? So it's 2x times the sine of 2 times x squared minus 1. Okay, so identities again. This will come in handy on the assignment. There's places where you want to be using them. And if you don't, it just doesn't mean it can't be done. It just means it's a lot more painful. And somebody else did it in 3 lines, and you're on your 2nd page now. And you know, like when stuff is building up. Okay, one more. Because if we've done higher derivatives and we've done whatever, then we should do implicit differentiation, right? So we can't express this as y equals, right? Not at all. There's no way. You can't write that as y equals. So we have to differentiate implicitly, right? So that means we take the derivative with respect to x of both sides. So the derivative of this is the cosine of x plus y. Okay, derivative of sine is cos, so derivative of something, forget what's in there, just the derivative of whatever's in there, times the derivative of what is in there, which is going to be, so that's 1 plus y prime. Right? So derivative with respect to x of x plus y is 1 plus y prime. Right? Just dy by dx, or y prime. Equals, okay, we got a product here, right? So it's y squared times the derivative of cos x, which is minus sine x, plus cos x times 2y y prime. Okay, the derivative of y squared with respect to x, which is 2y y prime. All right. Now it's just s. So now we got to expand the left side, leave the right side as it is, get the y primes on one side, get the not y primes on the other side, and divide it out, and we'll be there. So cos of x plus y times 1 is the cos of x plus y, plus the cos of x plus y times y prime. So now we got a y prime term here, right? By itself, not as part of something. Is negative y squared sine x plus 2y y prime cos x. Or maybe I should go, yeah, let's do 2y cos x y prime. Okay, y primes to one side. Let's pull this, so we'll go this. Cos of x plus y. Move this over so it becomes plus y squared sine x equals 2y cos x y prime minus cos x plus y y prime. Factor out the y prime, divide both sides by 2y cos x minus cos x plus y. And okay, so next step then is to factor out the y prime. So we've got the cos of x plus y squared sine x is equal to y prime 2y cos x minus cos x plus y. Y prime, isolate now, just divide both sides by this. So y prime is the cos of x plus y squared sine x over 2y cos x minus the cos of x plus y. There you go. The slope of the tangent line to whatever that original equation we started with, right? But had to be done with the implicit differentiation, okay? Because we could not, you couldn't write it explicitly in terms of y. Okay? So if you cannot explicitly write it in terms of y, you must use implicit differentiation.
What exactly does that mean? Like you can't write